Today we're going to do a quick lesson on sine and cosine of complementary angles. This is a fairly simple concept. It is just us noticing something that is similar between the sine of one angle and the cosine of the other. First, let's review what complementary angles are. These angles are angles that sum to 90 degrees. We can see in this picture here that we have an angle, a right angle, and then we have another segment that is cutting this angle into two parts. We do not know for sure that this is a bisector, so we cannot assume that. The only thing that we know for sure is that this part plus this part is going to give us a 90-degree sum. Another thing that we need to review is what is the sum of the degrees of a triangle. We know that if we add angle A, B, and C, we are going to get 180 degrees. So let's just look and see what the measure is of each of these angles. And we can quickly do that using this program. It's Geometer Sketchpad. It's a pretty fun program. We're going to measure angle B, and then we're going to measure angle C. And we see that we have, give or take, 48 degrees plus 62 plus 71. Well, I'm going to use this calculator, and I'm going to add each of these. And we can see that angle A plus angle B plus angle C is going to give us exactly 180 degrees. And this is true for every single triangle. So how can we use complementary angles, what we know about those, and what we know about the sum of the degrees of a triangle for right triangles? Well, the thing about right triangles is that we know that 90 degrees of that 180 is sitting in one angle. So here we have a right triangle of ABC. Our right angle is at angle C. So I know that I have 90 more degrees that have to be taken up in order for this to be a triangle. Well, if 90 is here, then I know that angle A and angle B added together have to equal 90 degrees. They're complementary angles. So let's go ahead and answer number 1. What do we know about angles A and angle B? We know that they are complementary. Again, we know this because this is a right triangle. Well, now let's go ahead and look at the relationships of the sine and cosine of each angle. First, let's find the sine and cosine of angle B. So angle B is going to be our reference angle. We know that for sine, we need the opposite over the hypotenuse. Well, we know our hypotenuse has to be 10 because it's sitting right across from the right angle. We also know that angle B is sitting right on top of 8, so it can't be the 8 can't be the opposite because the segment is helping make that angle. But if we look across, we see that 6 is on the opposite side of angle B, therefore 6 has to be the opposite. So the sine has to be 6 over 10. And therefore 8 has to be the adjacent because it is helping make that angle. So B is right next to it. So that leaves the cosine to be 8 over 10 because our hypotenuse never changes. So now let's change our reference angle to angle A. Now when we move up to angle A, we see that the segment 6 is helping us make this angle A. So 6 can't be the opposite of angle A like it is the opposite of angle B. That means that if we go across the triangle, we see that we have angle 8, or we have segment 8 right here. So 8 over 10 has to be our sine. Again, the hypotenuse never changes. So since we know here at angle A that the segment length 6 is helping make angle A, that 6 has to be the adjacent. So 6 divided by 10 has to be the cosine of A. So what are some things that we notice? Well, immediately I notice that I have 2 of each. So I see that sine B and the cosine of A are equal to 6 over 10. And I also see the cosine of B and the sine of A are equal to 8 over 10. Therefore, I can see that the sine of one angle is equal to the cosine of the other angle. And the cosine of one angle is equal to the sine of the other angle. And the reason why is because when we change the way we look at the triangle, that means that these two switch. Okay? So when I'm looking at B here, 6 is my opposite and 8 is my adjacent. But when I go up here to A, they switch. 8 becomes my opposite and 6 becomes my adjacent. Therefore, the sine of one angle is equivalent to the cosine of the other angle. Let's look at another example. So let's start at number 1. What do we know about angles A and B? Well, we're given a right triangle, A, B, and C. And without any measurements, we know that we have two complementary angles right here, A and B, because the degrees of a triangle add up to 180 degrees, and angle C is keeping 90 of them to itself because we have a right triangle here. So they are complementary angles. Okay, so now I'm going to use this program again and measure the length of each of my sides real quick so we can have some segment lengths. And I see that AC is 1.72, AB is 8.23, and then BC is 8.04. So what is the sine of B? What is the sine of B? So let's get back down here to our reference angle, and I can see that if I go across my triangle, that 1.72 is my opposite. My hypotenuse is the side that is sitting across from my right angle. So that has to be 8.23. Again, the hypotenuse never changes. So let's think about the cosine. Now, we can see that 8.04 is helping make this angle. So B is sitting on 8.04. So 8.04 has to be the adjacent. And again, the hypotenuse is 8.23. So now we need to change our reference angle to reference angle A. And we need to look at this triangle from angle A's perspective. Well, we see that 1.72 now is not the opposite because it's helping make angle A. So we have to go across the triangle to see that 8.04 is the opposite because it is across from A. And the hypotenuse is still 8.23. The cosine of A is going to be 1.72 over 8.23. Because 1.72 is helping make A. A is sitting on 1.72, so it has to be the adjacent. So again, what do we notice? Let's look at the sides and let's look at the ratios. We see that the sine of B and the cosine of A is equal to 1.72 over 8.23. And we see that the cosine of B and the sine of A is equal to 8.04 over 8.23. So we can see that the sine of B is equivalent to the cosine of A. Because when we change the perspective, we change the way we look at this triangle, these sides switch. So when I'm looking at it from angle B, I got opposite adjacent. But when I'm looking at it from angle A, I have opposite adjacent. So that's why the cosine of one angle is equivalent to the sine of another angle. So let's say we did not have these sides. What would you say if you were asked what is the equivalent to sine of B, and you're only given this picture? Well, I know that if I'm looking over here at sine of B, well, this side is going to be my adjacent regardless of the length, and this is going to be my opposite regardless of the length. So in order to get an equivalent, I need to look over here at angle A, and I can see that the adjacent here is the same as the opposite from B. So it would be the cosine of A is equivalent to the sine of B, because we're just changing our perspective. Therefore, the legs switch. Another way you might be asked this question is find the equivalent of the cosine of 83 degrees. Well, we could easily type this in the calculator and get a decimal, but Personally, I like to recognize the fact that 83 degrees has to be added to something to get 90. So I just take 90 minus 83, and I see that it's 7. So I know that the other angle has to be 7 degrees because it's a right triangle. And so since I'm looking at it from a different perspective, I know that the legs switch. So sine of 7 is going to be equal to the cosine of 83. We can verify this with our calculators, and we can type in the sine of 7, and we get 0.1219. And then we can type in cosine of 83, and we get the same thing, 0.1219. So let's look at a problem, another similar problem. We want to find the equivalent of the sine of 64. Again, we could type that in and play with different values to get it, but I like to notice that I have 64 degrees, so I know that the other angle has to be 90 minus 64, so that's going to give me 26 degrees. Since I'm looking at the 64 degree angle through the perspective of sine, I know that the cosine of 26 degrees is what's going to make my legs switch. So that's going to make the opposite, the cosine of the other angle is what's going to give me the same as the sine of the other angle. So the cosine of 26 degrees is going to give me the sine of 64 degrees. And again, we can verify this through our calculators, and we see that the cosine of 26 degrees is 0.8988, and the sine of 64 degrees is also 0.8988. Again, this is a fairly easy concept. It's just seeing that depending on how we're looking at the triangle depends on which leg is the opposite and which leg is the adjacent, and us recognizing that there's a relationship there. Again, if you have any questions, shoot me an email. There will be some practice problems that go along with this video uploaded momentarily. Thank you.